Recorded video will serve as the discussion of energy levels in an atom. So why I give you pre-recorded video than virtual discussion? As I've said yesterday, I will be giving you virtual discussion for energy levels in an atom, but I changed it. Why? Because we will be going to discuss the electronic configuration. When we say electronic configuration, it is quite hard to make it in virtual because since if you cannot understand it already, you can repeat it time to time in this process of discussions. So that's why I will give you a pre-recorded video. So now I've already discussed the structure of an atom and the chemical bonding. So I already perhaps discussed the orbitals or the energy levels. So now let's us just recall by this uh, type of topic of us, which is energy levels in an atom. So let's proceed to the main levels in an atom. So how can we get the levels of energy in a certain atom, or what does levels of energy mean in terms of structure of the atom? So there are following steps on defining or getting the levels of energy. First, the nucleus of an atom is positively charged because of its proton. That is actually a constant one. The electrons surrounding the nucleus are negatively charged. Yes, it is also a constant because in the inside of the illustration, I will be discussing that one later part. So in an atom, the third one in an atom, the number of proton equals the number of electrons. So in the representation in levels of an atom, or in the representation of levels of an energy, there are certain person who make an illustration that can definitely discuss or explain the levels of energy. Who is this person? Of course, Niels Bohr. Niels Bohr, he proposed that the movement of the electron is analogous to the planets orbiting around it. So as you can see in this structure, it's like orbitals, right? It's like orbits. So each circle of it is the energy level. So meaning to say, as we can see, the nucleus is the center of the orbits. So the first circle of it is the energy level 1, the next energy level 2, and the next energy level 3. So that explains how the levels of energy can be found in the structure of an atom. So as we can as I've explained a while ago, that electron is surrounded along the way or around the nucleus, but the proton itself is in the nucleus. Ganyan yung nangyayari kung bakit nagiging positive si nucleus, because in the nucleus itself is proton, while the surrounding of it in the orbitals is called electron. So each energy level has its own electrons, and the proton itself is in the nucleus. So that makes the explanation on the Niels Bohr's model. Okay, let's proceed now. When an electron is at the K shell is nearest the nucleus, hence it is most strongly attractive to the nucleus. It has the lowest energy. Yan, dito natin makikita in, okay, meaning to say that the first K shell, so yun na nga sinasabi ko, that the first circle in the orbitals, it's called K shell, or the energy level 1. So if the K shell or the energy level 1 is nearest to the nucleus, it is strongly attracted to the nucleus. Why? Because malapit siya, di ba? So that makes the K shell or the energy level lowest range. So the explanation of that, or what it means to say that kung saan mas malapit si key shell or energy level, kung mas malapit siya sa nucleus, magiging mababa yung range niya. So the more na malayo ka sa nucleus, the more magiging higher ang range mo. So that makes the explanation on the orbitals in energy level, or level of energy in the structure of an atom. So let's proceed. So let's go now to the sublevels of energy. I will not read it already kasi nababasa nyo naman yan, and I will explain it the easiest way to explain the levels of energy and the sublevels of energy. So if there is a main energy level, so as we can see this one, this this is the number of electron for the main energy level. Meron din tayo 1 for K, 2 for L, 3 or M. So that's it. So let's focus now to the sublevels. For sublevels, we have S, SP, SPD, SPDF, and we have SPDF sublevels. So I will be discussing that one furthermore. So in energy level, we have the number of electrons in a certain sublevel. So for S, we have 2. For P, we have 6. For D, we have 10. And for F, we have 14. So what are these sublevels, or the definition of the acronyms of sublevels? So let's proceed here. So these are the different sublevels of energy. It actually represented as S for sharp lines, P for principal lines, D for diffuse lines, and fundamental lines is for F. So again, the electrons that represented by each sublevels is only for S. For sharp lines is 2. For principal lines is 6. For diffuse lines is 10. And for fundamental lines is 14. Okay, let's go now. Let's focus now on how we can get the electronic configuration of a certain element. Papaano? It is very easy. Why? Because we have actually we have a pattern on how we can get the electronic configuration of each element. So by looking at by looking in this illustration, you can definitely know the pattern on how you can start to get the electronic configuration of a certain element. So first thing to do, or the first level of yours, we have 1s, sunod-sunod yan, 1s, 2s, for the second, 2p, 3s, 3p, 4s, 3d, 4p, sorry, and 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and 5f, 6d, 7p, and 8s. So the last one, the last number of the electronic configuration that you will be using is 8s. So sunod-sunod po yan. So how can we make it, or how can we get a certain electronic configuration? Let's make an example. So like this, as you can see in this one, in this part, by the following the arrow, like for example this one, this illustration, ito ang kailangan natin. Don't mind this one kasi ito yung mas madali. So this is actually the pattern on how you can get the electronic configuration of each element. By using this pattern, it's very easy na. But in examination and in my oral recitation, I will not be hindi ko kayo papayagan to use the pattern. So you have to memorize or familiarize the pattern o yung pagkasunod-sunod ng pagkasunod-sunod on how can you get the electronic configuration. So let's try to look in this one. I know you already know how to get the electronic configuration kasi some of you is a STEM. So it is actually a recall of or a review of yours. So this is the proper enumeration, proper way or the pattern. Yun na nga yung sinabi ko kanina. 1s2, 2s2, 2p, 3s6, 4s, 3d, 4p, 5s6, 4d, 5p, 6s6, 4f, 5d, 6p, 7s, and 7p, and so on and so forth. 7s, 5f, 6d, 7p, and 8s. Ito kasi hindi ko na pinatuloy. So that would makes the order of electronic configurations. And so let's have an example. So this is the summarization, or I actually make a summarized electronic configuration in each element. So by looking in this periodic table, you can actually get the proper electronic configuration of each element. So saan ba natin makukuha ang electronic configuration of each element? Of course, by its atomic number. So we will be getting the electronic configuration by its atomic number of an element. So how? Like for example, beryllium. So let's go for beryllium. What is the atomic number of beryllium? We have 4. Let's go to the easy way to easy to hard. Okay, beryllium we have 4. So let's take a look with the pattern. So it started with 1, 'di ba? For the pattern, it started with 1, then S, the electrons that is possible the electrons that can be used in S is 2. So it is 1s2. So the first electronic configuration in beryllium is 1s2. Next, 1s2, so meron ka ng 2 electrons. Hindi pa yun buo because the atomic number of beryllium is 4. So the next one would be 2s. Okay, for the next pattern, in order, we have 2s. Ilan pa rin ang sharp line? Of course, the electrons that can be used in sharp line is also 2. So, nabuo na natin ang atomic number, which is 4. So, the electronic configuration for beryllium is 1s2, 2s2. Yon. Okay. Another example. So, let's go now. Let's have argon. Malaki-laki na si argon. Argon, the atomic number of argon is 18. So now let's take a look with the pattern. So it started also with 1s, 1s2, meron ka ng 2 electron, 2s2, another 2 electrons, so it makes 4. Then 2p. Ilan nga yung electron ng p ng principal? We have 6. So 1s2, 2s2, 2p, 6. So it's actually 10. So we have 10 electrons already. So ilan na lang yung kulang so that we can make it to 18 argon? Meron pa tayong 8 na kailangan, right? So let's go now to 3s. Ang s naman, ilan na naman yung electrons na pwede? 2. So we have 1s2, 2s2, 2p6, 3s2, and lastly 3p6. Ilan na yon? It actually make the 18 or the atomic number of argon, which is 18. So 10 plus 8, it's 18. So that is the electronic configuration of argon: 1s2, 2s2, 2p6, 3s2, and 3p6. Always follow the pattern. Okay, from first pattern, second, third, fourth, fifth, and so on so forth. Follow lang yung pattern, yung arrow, nagsisimula talaga sa 1s. Okay. So, another example. We have, let's make it to, okay, let's have bromine for the next example. The atomic number of bromine is 35. Okay, so now let's go to the pattern. Okay, so since bromine is 35, so let's start with, again, 1s2. 1s2, you have 2 electrons now. Next, 2s2, another 2 electrons. It makes 4. Then next, we have 2p6 because the principal, the highest number of principal in terms of electrons is 6. So it's you have already 10. Next to that is 3s. So s is 2, another 2. You have 11, 12 electrons now. The next we have 3p6. For 3p6, you have already 18 electrons. May kulang pa because the bromine is 35. Then after 3p, next to 3p6, we have 4s2 for the pattern. So since it's 4s, sundin. So 2. So from 18, we have 19, 20 electrons. Then next to that, 3d. So d, the diffuse one is, you can use 10 electrons, right? So 3d 10, then 4. Next to that is 4 principal. So since magsasobra siya, if you can use a 6 in the principal or in the last one, you can use 5. Pwede siyang ipababa. Pwede mong ipababa yung what they call this, electrons in a certain energy, pwede mo siya ipababa in a certain electronic configuration. So from 6 pwede mo siyang gawing 5. So the electronic configuration for bromine is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p5. So always follow the pattern. Yan. So another example. Okay. So for another example, let's have fluorine. So the atomic number for fluorine is 9. It is very easy. So let's follow the pattern. We have 1s2, 2s2, and 2p5. So that makes the atomic number for fluorine 9. So this is the electronic configuration of fluorine: 1s2, 2s2, 2p5. Yan. So kaya nga sinasabi ko na pwedeng babaan yung certain electrons in a certain electronic configuration. Pwede, since it is 6, you can have it to 5. Okay? So that's it. That is the example on how you can get electronic configuration. So this is actually a summarization on getting it. Pero yung mga elements lang that is actually in 30 in atomic number. Pero as we all know that there are hindi pa ito kompleto. So the best way na lang on how you can get the easy way to get electronic configuration is to follow the pattern. Ito talaga siya. Once you memorize and familiarize the pattern, then boom, you can get the electronic configuration of a certain element. Okay? So let's proceed now to the last topic of this lesson. We have the rules for filling orbitals. Okay. We have actually 3 rules. Off-boop principle. So off-boop principle, it is literally the principle who is actually states that the electrons fill lower energy atomic orbitals before filling higher energy ones. So meaning to say, in off-boop principle, it is basically follow the lower energy, since it is the lower energy atomic orbitals, or the nearest or energy level, which is 1 in the nearest in the nucleus, so that it makes lower. So nagsusunod si off-boop principle that the energy level will start in the lowest orbital to the higher orbital. So that is the off-boop principle. So always remember that it states that it will follow, or the filling of the energy level or the energy in a certain atom will start in a lower to higher energy one. So next to off-boop principle, we have Pauli exclusion principle. In Pauli exclusion principle, it's very contrast to the definition or explanation of Buwai, because in Pauli exclusion principle, it states that no two electrons in the same atom can have identical values for 4 of their quantum numbers. Or it said that this is why each orbital only has 2 electrons. Okay. So, yun na nga sinasabi natin that in the orbitals, always the electron is outside the nucleus. So, meaning to say, in the orbitals, there is only 2 electrons. Always remember that each orbital only has 2 electrons. So, yun na nga, then electrons in the same orbital have the same first 2 to 3 quantum numbers. So yan. So that is the Pauli exclusion principle. It is very different to off-boop, kasi sa off-boop, it states from the lower to higher energy level. But in the Pauli exclusion, it focuses on the number of electrons. Okay? Let's go now to the Hans rule. Hans rule states that the orbitals of the same energy differ only in their orientation, are filled with the electrons with the same spin before the second electrons is added to any of the orbitals. If the Pauli focuses on the electrons and the off-boop focuses on the lower to higher one, Hans rule naman focuses on the same energy. It said that in the same energy, nagdi-differ pa rin siya kahit the same energy level yung atom, nagdi-differ pa rin siya in the orientation or in the process itself. Okay, so that makes the Hens rule possible. Okay, so that's it. That is the explanation or the discussion about energy level atoms. So don't worry, because in this topic we will focus on electronic configuration. How can you get the electronic configuration by each element? So always remember that you can get it. You can easily get the electronic configuration of an element if you will follow the pattern. So please familiarize and memorize the pattern on how to get electronic configuration. And how can you get the electronic configuration? By the atomic number of each element. So much for that. So much for the discussion for this morning. Thank you very much for listening. And if you did not understand it pa, you can repeat it since it is pre-recorded videos. So have a safe day, everyone, and thank you. Goodbye.